Welcome to the Non-Destructive Testing and Evaluation course. Course code is ME8097 for the regulation 2017. So in this video session, we'll be studying about the eddy current testing in the unit 3 and the introduction of eddy current testing. So in unit 3, thermography and eddy current testing. And in coming to the eddy current testing, we'll be studying about the generation of eddy current, the properties of eddy current sensing elements, probes, instrumentations, types of arrangements, eddy current testing applications, advantages, limitations, and interpretation and evaluation of results. So introduction to eddy current testing. So eddy current inspection is one of the several methods that uses the principle of electromagnetism, and this electromagnetism forms the basis for conducting examination. And there are several methods like remote field testing, flux leakage, and Barkhausen noise also use this principle. So eddy currents are normally defined as an oscillating electrical current which is induced in a conductive material by an alternating magnetic field, and this is due to electromagnetic induction. So eddy current testing can be used for sorting out the materials, measurements and controls of dimensions of tubes, sheets and rods, coating, thickness, and pre-service and in-service examination of heat exchanger tubes for the detection of defects. So making use of electromagnetic induction, and it is used to detect and characterize surface and surface flaws in the conductive materials. So the properties of eddy current. So eddy current density decreases with the depth exponentially. So this phenomenon is known as the skin effect. And eddy currents are nothing but it is a closed loops of induced current which is circulating in a plane, and that is perpendicular to the magnetic flux. And normally the eddy currents travel parallel to the coil winding, and the flow is limited to the area of the inducing magnetic field, and hence it is also perpendicular to the axis of the coil's flux field. So electromagnetic induction, this eddy currents are normally created through a process called electromagnetic induction. So when an alternating current, you can see from this figure, this is an alternating current which is applied to the conductor such as a copper wire. A magnetic field develops in and around the conductor. So this magnetic field expands as an alternating current and rises to the maximum and collapses as the current is reduced to zero. And here you can see this, and when another electrical conductor is brought into the proximity of this changing magnetic field, the reverse effect will occur. So this magnetic field and cutting through the second conductor will cause an induced current to flow in the second conductor, and hence eddy currents are a form of induced current. So how the eddy currents are generated, and eddy currents are induced electrical currents that flow in a circular path. So you can see here in the test specimen, you have this electrical current which flows in a circular path. They get the name from eddies. Actually, you can see from this figure and how the eddies are formed. Like when a liquid or gas flows in a circular path around any obstacles, and when conditions are right, these eddies are formed. So here you have a test probe, and this test probe has a coil here and an alternating current is applied here, and you can see this eddy current is formed on the test specimen in a circular path. So we'll see this animation of this, the generation of eddy current. So in order to generate eddy current for inspection, a probe is used. So this is a probe, and inside the probe is you have this length of electrical conductor which is formed in the form of a coil. And alternating current is allowed to flow in the coil at a frequency chosen by the technician for the type of test. Well, so you can see here this alternating current is supplied to the coil, and a dynamic expanding and collapsing of this magnetic field forms in and around the coil as the alternating current flows through the coil. So you can see here this dynamic expanding and collapsing of a magnetic field which is formed in and around the coil. And when an conducting material, so the bottom part is the conductive material, when an electrically conductive material is placed in the coil's dynamic magnetic field, electromagnetic induction will occur, and that eddy currents will be induced in the material as a circular path. So now you can see here this eddy current has been generated and the material of the test specimen. So this eddy current flowing in the material will generate their own secondary magnetic field. So this will generate a secondary magnetic field which will oppose the coil's primary magnetic field. So this is a primary magnetic field, and it will oppose the primary magnetic field. This entire magnetic induction process produce eddy current may occur for several hundred to several million times depending upon the inspection frequency. So eddy currents are nothing but the strongest at the surface of the material, and it decreases in strength below the surface of the material. And this depth that the eddy currents are only 37% as strong as they are on the surface. It's known as the standard depth of penetration or the skin depth. So standard depth, you have the standard depth here, and 37% strong as they are on the surface, and known as the standard depth penetration or the skin depth. So this depth changes with the frequency of this probe material and the conductivity and permeability. So here you have this high frequency, high conductivity and high permeability because the standard depth of penetration is you can see from the figure. And here you have the standard depth of penetration at some lower level, and hence eddy current density you can see has a low frequency and low conductivity and low permeability. So principles of eddy current testing, and here an alternating current of frequency 1 kilohertz to 2 megahertz is made to flow in a coil, so which will in turn produce an alternating magnetic field around the coil. And when this coil is brought close to the conducting material, electrically conducting material, that is the metallic material to be inspected, an eddy current is induced in the material due to this electromagnetic induction. And normally this eddy currents are generally parallel to the coil winding. And the presence of any defect or discontinuity in the material will disturb this eddy current flow. So likewise, you can find out the defects on the test specimen. So coming to the application of eddy current testing, and this eddy current testing method is used for detecting discontinuities as any surface breaking cracks, and conductivity measurement can be done, and tubes can be inspected, and thickness measurement can also be done. So these are all the advantages of eddy current testing. And here it's very sensitive to small cracks and other defects, detect surface and near surface defects. And on inspecting, this eddy current testing method gives immediate results, and you can easily carry the equipment from one place to another. Methods can be used for much more than flaw detection, and minimum part preparation is enough. And here the test probes does not need to contact the part. You need not bring the test probes in contact with the material that you are going to test. So complex shapes and size of conductive materials can also be inspected by using this eddy current testing method. And eddy current testing also has limitations. So here only conductive materials can be inspected, and this material surface which you are going to test should be accessible to the probe. And the skill and training of the tester of the labors required, and it's more extensive than other techniques. It's more expensive, I'm sorry. Surface finish and roughness may interfere, and reference standards needed for setup. Depth of penetration is also limited, and delamination that lie parallel to the probe coil winding and the probe scan directions are undetectable. So with this, we come to an end with this eddy current testing method of introduction. So thank you and have a